Okay, welcome to this presentation. We're going to talk about the if statement today. Make sure we understand the syntax of that. And we're also going to look at the test that we do as part of the if statement. So it's a logical test, and it's going to introduce a new type to us called Boolean type. And hopefully we'll get our mind around that and how we construct it. So I'm sure most of you have come across the concept of an if statement before. You may have done some other programming languages such as Scratch. Or Java or C or whatever, they've all got this if statement in there. And to be frank, unless you can implement something like the if statement, there's not a lot you can do in programming, because this is the point now we allow a program to go down one route if a certain condition happens, otherwise we'll go a different route. So the program can take different paths, i.e. execute different instructions based on some test, and we'll look at how that works. So the most important part of the if statement really is this test that we've got, up here, and it's understanding what this test is really will get us on with the code. So going on to the next slide. So far we've come across three different data types. We've looked at integers, which we know are obviously whole numbers, positive and negative. We've looked at strings, which we know are a sequence of ASCII characters, and we've looked at floating point numbers, which we know are obviously numbers with a decimal point in. What we're going to talk about now is a new type of variable or a value, a new data type in Python called Boolean, and all programming languages have this type. Boolean can take on one of two values. It can either be true or false. So it is a data type and it's a true or false. It's only got two possible values, which incidentally means we can store it in a single bit. Not that we do, because it would be very difficult to manage individual bits. So it's typically stored in a byte or a couple of bytes, and a 0 represents false and a 1 represents true. So how do we create one of these Boolean types? What makes a Boolean type? Well, a Boolean type is a result of an expression. So you can see down here we've got this expression, age greater than or equal to 18. Go back. Age greater than or equal to 18. So age greater than or equal to 18 is a test. It's using a test comparator here, a greater than or equal to. It's got two operands, they're called, either side. The one on the left is a variable age. The one on the right is a numeric value 18. And quite obviously it's testing to see if age, whatever's in the variable age, is bigger than or equal to 18. Now the result of that test will be true or false. It can only be one of those two possibilities. So the result of this comparison expression, age greater than or equal to 18, results in a new data type called a Boolean, which is true or false. And in this particular example here, we're then assigning that to a variable called legal. So legal is a variable storing a Boolean operator, in this case true or false. So why have we called it legal? Because obviously legal, the way we've determined it within use in our program, may well be that this means the person is of legal age. So you can now, because legal is a Boolean type, you can use simple constructs like if legal, go on and do something, because it's a Boolean type. Obviously we can statically assign Boolean types as well. So for whatever reason, if we've got some variable called brown eyes and our particular person has got brown eyes, we can assign brown eyes the value true. Notice it's capital T, and if you type it in idle, it will indeed come up color coded because it's a reserved word. Okay, so that gives you the concept of a Boolean type. Let's just have a look in a bit more detail how we actually generate them. So we've come across the equality test before. You'll see this is why I've been trying to get everybody to use the fact that a single equals is an assignment statement, whereas a double equals, which we've got here, is a test of equality. And this is used to test if two things are equal. So here I'm testing if the variable name is equal to the string George. So obviously if the variable name contains a string and the string is George, exactly like it is here, same capitalization and everything, then these two will be the same and this expression will return a true. If the name is not George, excuse me, then this expression will return a false. We've also got greater than or greater than to equal signs. Excuse me. And we can use those. We've seen those just used a moment ago. Here they are. We're now testing a variable height to see if it's greater than or equal to 2000. So this would, if somebody's height is bigger than 2 meters and we're storing it in millimeters, then this here will return a true value. Sorry, if it's bigger than or equal to 2 meters, 2000 millimeters. We can also use the greater than sign to compare strings, which seems a bit odd because clearly strings are letters, and how can we compare letters being greater than or equal to? Well, what Python actually does is quite sensible when you think about it. It looks at the ASCII values of the characters, and it starts with the leftmost character and goes along and compares them. So if we were comparing Bill and Bob, as we are here, it would compare the capital B to the capital B, and it would say, right, they're the same, so I've not proved that Bob is greater than Bill. It would then look at the O and compare it to the I. It would look at the ASCII value for O. It would compare it to the ASCII value for I. Now obviously, think about the alphabet, A, B, C, D, F, G, H, I, J, K, L, M, N, O. O is further on in the alphabet, so it has a higher ASCII value. So because the second letter here has a higher ASCII value than the second letter here, then obviously this value is bigger than that value. So in this particular case, Bob is greater than Bill, and this expression, Bob greater than Bill, would return as a true result. We've also got the less than or less than equal sign, which is just the same as we've looked at, but obviously in reverse. And again, here, if we do it with strings, then we compare it letter by letter. So here's one I just kind of figured out earlier on. Big is indeed less than small, which is quite weird, but why is big less than small? Why does big less than small return a true value? Well, obviously the ASCII value for B is lower than the ASCII value for S. So the result of this expression, big less than small, is indeed true. The one you may not have come across before is a greater than or equal sign. So, sorry, not greater than, a exclamation equal sign. An exclamation equal sign is a not equal to. It's the negation of an equality. So this proves that, or is asking the question, are two things equal? So we might have an expression like this: passcode does not equal the string $12 star DJM. What does this mean? It's a test to see if the passcode is not that particular string. If it's not that particular string, then this expression would return true. If my passcode, or the passcode that's typed in, is $12, then this would return a false, because they would be equal. Now you can get yourself tied in knots here if you're not careful with this not operator. It's not always obvious how you use it. Sometimes it makes perfect sense to talk about something not being equal, because that's more logical in the way we talk about it. So you may come across as using this. Depends on the context, obviously, but just be aware of it. So just having a quick look at that, let's just open up an idle window. So here we are in idle. Let's just do a couple of things to see what we've talked about. So if I do 7 greater than 8, is that true? Is 7 greater than 8? Obviously the answer is no. So that returns me a false value. If I did 8 greater than 7, obviously that returns me true, because that is a true value. So I could say pass. Well, now what I'm going to do is create a variable called score and give it 50. I'm going to say pass is score, or is assign the value score greater than 40. Oh, sorry, it would have helped if I typed in the syntax right. Pass. I can't use pass, it's come up in orange as a reserved word. So I'm going to say passed is assigned score greater than, get it right in a minute, 40. Okay, so what's gone on there? We've set a score to 50. We're doing the test score greater than 40. Well, score is 50, so it's true that. And it's assigned the result of this, which we think is true, to the variable passed. So I can just ask it to print passed, and indeed, there you go, it's true. A really minor point, if you've not noticed this before, when you're at the shell window, we can just type in the variable and it will just give me the value of the variable. We don't actually have to use the word print. So that's it. So that's pretty straightforward. And we did Bill being greater than Bob, so let's just see what that does. Bill string greater than Bob. false. Oh, I spelled Bill right. So what have I done here? ABC. Oh, I did it the other way around. Until Bob was greater than Bill. Right. So just again going through why this is. Two capital B's are the same. ASCII value of I compared to the ASCII value of O. I is obviously first in the alphabet, so it's got a lower value. A, B, C, D, F, G, H, I, J, K, L, M, N, O. So I is a lower value than O. So in fact, Bill will be smaller than Bob from an ASCII point of view. So we're doing a test to see if they're bigger, and obviously it's returned false. If I, just to prove it, do Bob being greater than Bill, spelling right this time, now it assigns the value true. So we've got these expressions here. The most important thing to remember is whenever we've got an equality, that's a double equals, a greater than or a greater than equal to, a less than or a less than equal to, or a not equal sign, the result of that expression is a new type, and it is a Boolean type, and it has the value true or false. What do we do with it? Well, we can use it straight away in the test. So we can say if Bill is greater than Bob, I'll do it the other way around, sorry. If Bob is greater than Bill, so we can do this as a test. So our expression here is now returned a true or false, and we've used it straight away as part of the if statement, or what we can do is store it in a variable and say the answer is Bill greater than Bob, so the true value gets stored in a variable called answer, and then we can just use answer as a Boolean later on. So I can now do things like if ans, because answer is a Boolean variable and therefore is allowed to be part of an if statement. Okay, hopefully that made sense. Let's go back and look at the rest of the presentation then. So what else can we do with Boolean types and these comparisons? Well, after having calculated a true or a false or done some tests, we can combine those with other tests. And this is where we introduce the words and or, and the word not. So what does and do? Well, and is a way of combining two Boolean tests, and overall the result is true if both of them are true. So if you're into logic gates, this is like an AND gate. If you're just into English, it's English, obviously, because when will the result of all this expression be true? Age bigger than 21 and sex equal to a capital F. Well, it will be true when both of them are true. That's what the word says, isn't it? It says age greater than 21 and sex equal to F. So both must be true for overall the expression to be true. So this is how we combine various conditional statements to give me an overall true and false. So to reiterate again, if we've got an and, both of them must be true for the overall result to be true. The contrary to that is the or statement. In the or statement, it doesn't matter which one of them is true. Either one can be true, or indeed both could be true. It doesn't matter. As long as one of the conditionals is true, overall the result is true. So in this particular case, we're testing if the temperature is bigger than 100 or the pressure is greater than 5. So if either of these conditions is true, the overall result is true. And I need to go and turn off the engine or whatever the case is. You can imagine both of these being some kind of safety test, that if it goes over 100 degrees or the pressure goes over 5 bar, I've got to switch the engine off. I don't need both of them to be true, but either one can be true and the engine needs to be switched off. Last one is a not statement. So not is the inverse. So in fact, exclamation mark equals is the same as not, and then your conditions with a double equals in between. It negates whatever you've said, so it just turns it into the opposite. So what you could imagine is you've got a Boolean type called passed exam, and this is true or false if somebody's passed an exam. But what you might want to do is to do something if they haven't passed the exam. So you need to negate it. So if you say if not passed exam, so imagine the person had passed the exam, this would be true. So if not passed the exam would be false. And obviously it would go on because this person had passed the exam. If the person had failed the exam, the passed exam variable would be false. So we're now saying not false, which is true, i.e. you go on and do something because the overall statement is true, because they didn't pass the exam. Okay, that might have blown your head away completely. It's one of those things you've got to play with, really. and start using it for real for it to make sense. The whole concept is it should read like English. That's why it's written like this, to make our life easy. But in English, we're not very good at managing inverses in our dialogue. So it does get a bit confusing if you're not, kind of strong on understanding the syntax of it. Obviously now we've got the ability to combine all of these various statements, doing all these individual tests and combining them with ands and ors and nots. There are rules a bit like BODMAS about which processes you do first. To me, forget it all, just put brackets around everything. If you put brackets around it, it's pretty clear what you mean and the order you want things done in, because obviously brackets always get evaluated first. Okay. Sorry, went the wrong way then. So, how does that help us? Well, we started saying we were going to talk about the if statement. What we've done now is we've understood how we write that conditional part of the if statement, how we generate the true or false value that the if statement is testing. So however we arrive at a true or false value now with the if statement, we then go and execute different bits of code depending on the results. So in the simplest case, we've got a straightforward if, and we've drawn it two ways here so you can visualize what's going on and see the code. So fundamentally over on the left, our code is executing and it comes in and it hits an if statement. In this case, I'm just testing two variables, A and B. And I'm saying if A is the same as B, so that they contain the same values. So if that is true, because A and B are the same, containing the same values, it's true. So we go and execute a particular block of code. So this block of code here, block 1, could be a single statement or multiple statements, it matters not, is only executed if A and B are the same. If A and B are different, then we go down the false route, and the false route just goes on to the block 2 of the code, which is obviously the next block of code. Because if you finish block 1, because it was true, you've come down here and you've gone on to block 2 anyway. So block 2 gets executed no matter what. Block 1 is the only kind of conditional block, and that's only executed if A and B are true. A is equal to B. What's the syntax like? Look for that. Well, it's our if statement and then our test of equality or a variable, and then very importantly a colon at the end. You've seen the colon before whenever we've got a loop statement like a for loop or something happening, the potential for a block of code to exist. That's really what the colon means. So when you put your cursor here and you do colon and hit return, you'd find the cursor would come here indented, typically 4 spaces. That now marks the start of a new block of code. And you'd put your statements in here where it says block 1. You might have a single statement or you might have multiple statements in there. It doesn't matter. If there are multiple, they all need to be indented at least 1 block. Our block finishes where the indentation ends, and now we're out of the block and we've got down to block 2 here. So in terms of understanding how this code works, what happens is block 1 is only executed if A and B are the same. And then no matter what you've done, if you've executed block 1, you carry on to block 2. If they weren't the same, then you didn't execute block 1 and you came down to block 2 anyway. Okay, hopefully I've laboured that enough. That one should be pretty clear. Next one to look at is, I might want to do something if the answer is false. So obviously in the previous one, only if A and B were the same did we actually do something special. And if it was wrong, we didn't do anything. We just kind of carried on with the program. In this particular case, what we want to do is come down here and we want to test if somebody is not equal to 18. So if they're not 18 years older, so remember this is a negation, so if they are not 18, you're going to go down the block 1 route and you're going to execute this code for block 1. If not equal to 18 here is false, which means they are 18, then you come down here and you execute this block of code here, block 3. Irrespective of which way you've been, whether you've been the true route and done block 1 or the false route and done block 3, the 2 bits of code then come together and you carry on block 2 with the rest of your program. What does the syntax look like that? For that, well, here it is. It's the if statement and our conditional test. Yeah, I realise I've got the conditional test wrong here. I've got my old one, A equals B. It matters not. You've got a conditional test here. If the test is true, you execute block 1. So we've come down this particular route here. And then the syntax is else. Now you'll notice the else has got a colon on. and that means that again more statements could follow. So this block 3 could be a single statement or multiple statements. Again, it matters not. So this is only executed if the false condition occurs. So if the age was not 18, we'd go down this route into block 3, execute whatever commands are in here, and then come out the bottom. Here it is in our code. The block's ended because the indentation's ended, and we're now back into block 2, and we're down here carrying on with the code. So that's our if-else construct. And again, just to reiterate, notice after the if statement and the conditional you've got a colon, and then your code is indented, the block that's executed if the if is true. You've got else colon, and the else lines up with the if, else colon, and then the next block again is also indented because this is part of the else statement. This is executed as a result is false. Okay, so that's the if and then the if else. What else can we do? Well, just to blow your mind away, in other languages we have a different way of doing this. It's called a case statement. We don't have that in Python, so we can implement the same concept with what we call an elif statement. It sounds very complicated to start with, but honestly, again, it's really straightforward if you think about it. So what's happening here? We're coming down and we've got a simple test here. If the volume is equal to 100, we want to go and do something. But what we want to do now is different things depending upon the value of the volume. It's not just if it's 100, do this. If it's not, go do something else. I want to do a different test. So if it wasn't 100, do something, and then do a different test. And if it's that, do something. Do a different test. And typically we use this kind of construct for a range of values. So in this particular case, we could imagine the volume in some system is 100, and if it's 100, I need to do something else. If it's got a level between 50 and 100, I need to do something different. If it's between 25 and 50, I need to do something different again. And if it's below 25, gosh, I've really got to do something different. So what we're doing is being able to essentially test the variable volume, and depending which range of values it's in, or whatever combination of tests we want, we can get it to do different things. So how does it work? Well, again, we come in at the top here and we say if the volume is 100, that's true, it'll go here. So it will execute block 1 if the volume is 100. And think about the construct we've had before, and we've said else. So else sends us out the false route. But now our else, as well as sending us out the false route, is going straight into another if statement. So it seems sensible to combine the else, which is the false route from one if statement, with the if, which is the next block you're going into. Hence we get this construct elif, else if. So starting at the top again, if it was 100, we do block 1. If it wasn't 100, we come down this route and we check the volume again and see if it's greater than 50. If it is greater than 50, then we go down this true route here and we execute block 2. If it's not greater than 50, we go down the false route, and so on. Just coming back to this statement here, think about what this actually means. Sorry, on the wrong way again. Think about what this statement means. I can only get down to this block if the volume wasn't 100. Now, imagining my maximum volume is 100 anyway, I can't go above there. If I've come down to this block, I know now that it wasn't 100. So in fact, this block is only executed, the true, if it's greater than 50 and not equal to 100. So we've actually effectively got a range here because I've hived off the top of the range by my first if statement. I've got rid of the possibility of it being 100. So now this statement is greater than 50 and by inference it can't be 100 either. So this is effectively in the range 50 to 99. So it goes off and does a true statement and does block 2. If it's less than 50 or equal to 50, come to that, it will go down here in another elif statement. And this elif statement is checking for greater than 25. If it's bigger than 25, it goes true. And again, think about it. It couldn't have got down here unless the volume was less than or equal to 50. If it had been, it would have gone somewhere else. It would have hit true on the previous statements. So this is effectively a test that it's in the range 25 to 50. And that executes block 3. So the else here, now this is a standard else because we're not going into an if block at this point. The very last one has got an else, which is kind of a catch-all, go to block 4. So it only gets down to execute block 4 if it's in the range, well, the range below 25, whatever that is. And irrespective of which of the blocks it does, it then gets out of the loop, goes to the very end, and finishes and carries on with the code, in this case block 5. What does that look like from a programming point of view? Well, here's our syntax. You'll notice again we've got the if statement and the test followed by a colon. We've then got our indented statement or statements, and then the elif lines back up with the if. The end of the elif, surprise surprise, has got a colon, again with indented blocks, and so on. And the last one, our catch-all, is our else statement, colon, and then again indented to block 4. And then at the end we finish off with block 5. So that's looked at the possibilities of the if construct, the basic if, the if else, and the if, elif, and else options. Now they do take a bit of time getting your mind around. Some of the simple ones seem to be straightforward, but part of the skill of being a programmer is being able to take the idea, abstract the raw facts that you want from it, and think about how you would use expressions like these to turn those ideas, those decomposed concepts, into actual code. Okay, hope that was useful. Thank you. Bye.